Hi, hello, welcome to one more session in haloalkanes and haloarenes. Today I shall discuss some tricks to solve some exemplar questions from the topic SN1 and SN2, which will be more useful for you to attend the board exams with much confidence. So before starting, let us have a quick recap on the important points to remember while dealing with this SN1 and SN2 reaction. Fine. SN1 mechanism. What is the first point? It's a unimolecular reaction and it's a two-step process. Normally tertiary alkyl halides will be undergoing SN1 mechanism fast, and also it depends upon the stability of the intermediate carbocation. See, whenever you're dealing with this SN1 mechanism, you should always have this trick in mind. So what's the trick, students? See, SN1, if it is SN1, you should have in mind 1, 2, 3. So what this 1 represents? See, the 1 means it's unimolecular, 2 means it's a two-step process, 3 represents tertiary alkyl halides. Okay, so this will be easy if you are having. You should always have certain tricks in mind so that you can easily understand the question and you can easily solve the questions. Okay, so 1, 2, 3 represents SN1 mechanism. If it is SN2, then you should have in mind 2, 1, 1. So what this 2 represents? 2 represents it's a bimolecular reaction, 1 represents it's a single step process, and 1 represents it's a primary alkyl halides. And normally primary alkyl halides undergo SN2 mechanisms very fast. Understood, students? So all these points you should always have in mind while dealing with this SN1 and SN2 type of reactions. We shall see the problems now. Students, consider the following chlorides and you are asked to find out the correct order of SN1 reactivity. See, 3 types of chlorides are given. Okay, so let us find out which chloride will be undergoing SN1 reaction fast. Okay, see, just we'll write the equation. This is a skeletal structure is given. We'll write what is A first. See, this is CH3, CH2. Then CH2, then CH2, Cl. Okay, so this is the normal structure. Okay, this is the normal structure of this compound. Okay, then what is B? See, B it is CH2 double bond CH, CH, Cl, then CH2, then CH3. Okay, so this is the second compound, and we'll write the third one CH3, CH2, CH, then CH2, then CH3. Okay, so this is Cl, right? So this is the third compound. Now we are supposed to find out which will be undergoing SN1 reaction fast. Normally SN1 reaction will be undergoing fast in the tertiary alkyl halide, and then secondary, and then primary. This is the order, and here we should consider. See, actually in these compounds we should consider the carbocation. See, normally SN1 reaction depends upon the stability of the carbocation. See, after the removal of this chlorine, this compound will be forming a primary carbocation. This will be forming a primary carbocation, and after the removal of this chlorine, this will be forming a secondary carbocation, and this also will be forming a secondary carbocation after the removal of. But see here, see this compound number B. See, this is a allylic carbon. What do you mean by allylic carbon? If the functional group is attached to a carbon atom which is next to a double bond, we call that group as allylic. Okay. So now normally this secondary carbocation which is formed by this allylic carbon will be more stable when compared to the secondary carbocation, and also more stable than that of the primary. So we should give preference to this one, the secondary allylic carbocation. Since the stability of the secondary allylic carbocation is more than that of the secondary carbocation and then that of the primary carbocation, this is the answer. So this secondary allylic carbocation is more stable. Okay. So why it is more stable? Because of the delocalization of electrons on the carbon atom. So this allylic carbocation is more stable due to delocalization of electrons on the carbocation. So the order should be like this. So let us check where this B comes. So B here we have B, and the second one is this secondary carbocation will be undergoing SN1 reaction fast. So C, and then comes A. A. So this is the option, students. So this is the correct answer. B, C, A. Understood? Which of the following is the correct order of decreasing SN2 reactivity? See, they are asking you to find out the compound which is undergoing the SN2 reaction fast. So in the decreasing order you want to write. So three types of compounds are given: R2CHX, R3CX, RCH2X. Where R represents, see, R is nothing but it's a alkyl group. Let us have this CH3. Let us consider CH3 as the alkyl group, and X represents a halogen. Okay, X represents a halogen. Now we'll write all these compounds first. We'll find out which is primary, which is secondary, and which is tertiary. So let us write one by one. R2CHX. What do you mean by R2CHX? See here the halogen is attached to a carbon atom which is further attached to two more alkyl groups. That means it is a secondary. It's a secondary alkyl halide. The next one is R3CX. R3CX means, see here the halogen is attached to a carbon atom which is further attached to three more alkyl groups. That means it is a tertiary alkyl halide. The next one is RCH2X. See here this halogen is attached to a carbon atom which is attached to one more carbon atom. That means it is a primary alkyl halide. See this SN2 mechanism, normally it takes place first in this primary alkyl halide, and then comes secondary alkyl halide, and comes the tertiary alkyl halide. So you should choose an option in such a way that the primary alkyl halide should be the first compound which undergoes SN2 mechanism very fast. So where we have this primary alkyl halide, here we have RCH2X, and here also we are having RCH2X. So these two options, and from these two options we should check the final one. So where we have the secondary alkyl halide R2CHX, here we are having R2CHX, but here we are having the tertiary alkyl halide. So the option will be the C. This is a primary alkyl halide, and this is a secondary alkyl halide, and this is a tertiary alkyl halide. So this is the decreasing order. Okay, they are asking you to find out the decreasing order of SN2 reactivity. So here this primary alkyl halide undergoes first, then comes secondary, then comes tertiary. So the option C is correct. Understood, students? Read the question, students. Which will react faster towards SN2 reaction with OH minus? Why? See, they are asking you to find out the compound which undergoes SN2 mechanism during the substitution reaction of with OH minus, and they are asking the reason why it happens. So normally we know that SN2 mechanism takes place fast in the primary alkyl halide, next comes secondary alkyl halide, and next comes tertiary alkyl halide. But here we'll find out. See, we are having four types of compounds, and this CH3Br, obviously it is a primary alkyl halide. CH3 alkyl halide is it is also a primary alkyl halide. Here the chlorine is attached to a carbon atom which is attached to three more carbon atoms, so it is a tertiary alkyl halide, and this is also a primary alkyl halide. So all three options are primary alkyl halides. Then how to find out the SN2 mechanism? So we cannot move with this reason, right? So we should opt for the next reason. So we'll take into account the leaving group here. See, three types of leaving groups are here. In the first compound, bromine is the leaving group, and the second iodine is the leaving group, third one chlorine is the leaving group, and the fourth one is also chlorine. Okay, so three types of functional groups are there: bromine, iodine, and chlorine. So among these three, we should check which one is the best leaving group. Obviously iodine is the best leaving group because it can accommodate since it is having a large size, it can accommodate the negative charge furnished by this alkyl groups while leaving. So all the other groups, they are smaller than that of iodine. So iodine is the best leaving group. And also one more thing, the bond dissociation energy of this iodine is very less when compared to bromine, chlorine. So this is the option. CH3I is the option. Okay, so the correct answer is CH3I. This is the compound which undergoes the SN2 reaction very fast when it is reacting with this OH. Read the next question, students. Isopropyl chloride undergoes hydrolysis by SN1 mechanism or SN2 mechanism or both SN1 and SN2 mechanisms or neither SN1 nor SN2 mechanisms. See here they are asking you to fix the type of mechanism through which this isopropyl chloride undergoes hydrolysis. Okay. First let us write the structure of this isopropyl chloride. CH3, CH, CH3, Cl. Okay, so obviously it is a secondary alkyl halide. Normally, if it is a secondary alkyl halide, it can be, there is a probability, right? It can undergo SN1 and SN2, but we are supposed to fix this now. So let us check the first one, that is SN1 mechanism, whether it is possible or not. See, if we are removing this chlorine from this isopropyl chloride, it will be forming a secondary carbocation. Okay, so it will be forming a secondary carbocation. Carbocation. See this carbocation, etc. I have explained in the previous session. So just please check if you are having any doubt. So after the removal of this chlorine, it will be forming a secondary carbocation. See, this secondary carbocation is more stabilized by plus I effect of these two methyl groups. See, what will be plus I effect? See, these methyl groups, they are electron donors. Okay. See, electron donors, this two methyl groups, they will be donating electrons to this carbocation, secondary carbocation, and it will be stabilizing the secondary carbocation. Okay, so this donation of electrons by the alkyl group is called as the plus I effect. So due to plus I effect, this carbocation is more stabilized. If the carbocation is more stable, obviously that particular compound will be undergoing SN1 mechanism very fast. So SN1 mechanism is also possible is possible in this isopropyl chloride. But when you are taking into account one more reason, see this compound is having two methyl groups. Okay, but this if we are taking into account steric hindrance, this is not much hindered by methyl group. If one more methyl group is also there, then we can come to a conclusion that if it is a since more steric hindrance is there, this is not possible. That is what to say. SN2 mechanism is not possible, but this compound is not much sterically hindered by methyl groups because this area is free. So the OH minus or whatever may be the nucleophile, it can easily approach this carbon, okay, carbon, and attack this carbon, and SN2 mechanism can easily take place. So obviously this isopropyl chloride, it can undergo SN1 mechanism as well as SN2 mechanism. Since it is less sterically hindered, it can undergo SN2 mechanism, and moreover secondary carbocation formed by this isopropyl chloride is more stable, so it can undergo SN1 mechanism. So this is a compound which can undergo both SN1 and SN2 mechanism. Understood, students? Let us read the next question. Which of the following haloalkanes would undergo SN2 reaction fast? See here, four types of alkyl halides are given, haloalkanes are given. Let us write the name of the compounds first so that you can understand. This is cyclohexyl methyl chloride. Methyl chloride. Understood? And this is cyclohexyl chloride. That you know, right? Cyclohexyl chloride. And this is a butyl chloride. So butyl iodide. And this is butyl chloride. Okay. Now you are asked to find out which will be undergoing SN2 reaction very fast. See here, here also we should take into account the leaving group. Okay. Since this here we are having Cl, here Cl, and here we are having I and Cl. This compound, that is compound number C, that is butyl iodide, will be undergoing this SN2 reaction fast because iodine is a better leaving group because it can accommodate the number or the electrons furnished by this alkyl halide while this iodine is leaving. Okay, so this is the first compound which can undergo the SN2 reaction very fast. Read the question, students. The order of rate of hydrolysis of alkyl halides primary, secondary, tertiary and methyl halide by the SN2 pathway is. See, they are asking you to find out the order of rate of hydrolysis. That is, they are asking you to find out which compound will be undergoing the hydrolysis first by SN2 pathway. Means you are asked to write in descending order. That is, which will be undergoing first and then next. Okay. So this is obviously CH3X. So CH3X, how will you write CH3X? Carbon, then hydrogen, and this here we are having hydrogen, and this is X. Okay, see this methyl halide, here the halogen is attached to a carbon atom which is further attached to three more hydrogen atoms. These are smaller groups, so the nucleophile can easily attack the carbon atom from the back side. Okay, so SN2 mechanism, the attack will be from the back side, and so it is easy. This CH3Ex, it will be undergoing the SN2 mechanism very fast, and next comes the primary alkyl halide, and next comes the secondary, and next comes the tertiary. So based on this we should fix the answer. This is the first one, this is second one. So check the option, students, where we are having this this type. Here this option C is having this answer, CH3X, primary, secondary, and tertiary. Is it not? So this is the answer. Okay, this is the answer. So we are having this as the answer. Read the question, students. Among the choices of alkyl bromides, the least reactive bromide in a SN2 reaction is. See, they are asking, they are given 4 types of compounds, and they are asking you to find out the compound which is least reactive towards SN2 mechanism. Okay, first we shall write the structure of the compound so that you can easily find out which alkyl bromide will be undergoing the least SN2 reaction, the least. Okay, so the first compound is, it's a pentane, so CH3, CH2, 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 and CH2 is one bromo, so we should write bromine in the first carbon. So this is A. Next we are going to write the compound 2, so CH3, CH3, so CH2, CH2, CH, CH2, here we have Br, and here we have in the second position we are having a methyl group. Okay, and understood. So let us write the third compound, that is C. It is CH3, CH, CH2, CH2. So it is one bromo. So in the first position we shall write bromine, and in the third position we shall have a methyl group. Okay, so it is one bromo, 3 methyl butane. Okay, and the fourth compound is, students, it is CH3, CH2. So in the second position we are having both bromine as well as the methyl group CH3. Okay, so these are the structures. Now we should find out which is more least reactive. So normally this is a primary, since the alkyl halogen group is attached to a carbon atom which is attached to one more carbon. So it is a primary, and here this is also primary because the halogen is attached to a carbon atom which is attached to one more carbon atom. And check this one, this is also primary because the halogen is attached to the carbon atom which is attached to one more carbon atom. But here, see, check this one, this is tertiary because the halogen is attached to a carbon atom which is attached to three more carbon atoms. So it is tertiary. Normally this SN2 mechanism, it is least reactive. That is, tertiary alkyl halide will not undergo SN2 mechanism. It is primary alkyl halide is more prone to SN2 mechanism. So the option is D. This is the correct option. Okay, answer is D. This is because it's a tertiary alkyl halide. Understood, students? Fine, students. You must have understood all the questions and its solutions clearly. We shall meet in the next session. Until then, it's Anita Raj signing off from you. Thanks for watching.